So we're going to continue on with probability, estimated probability using different types of simulation. We're going to do another one today. First question, which one doesn't belong? Again, you can make an argument for probably all of them, but I'd like to know what you have to say. Leroy.
The top right one, it doesn't have red.
Top right one doesn't have red. Not wrong.
The bottom left one is too much red.
Too much red. The only one where there's a majority of red. Yeah.
Bottom left one, because it's only one with like 1/4 of it with 2 colors.
What?
That's not 1/4.
It's the only one with 1/4 of it of 2 colors.
That's not 1/4.
That's a little more than 1/4.
Less. That's a little less than 1/4.
Yeah.
Top right because they're all equal. Top left because they're all equal.
Only one that's all equal. Dakota.
Too big.
Top right because it's only one divided into 3.
Only one that's got 3. Okay, so nobody's chosen this one.
Yeah, I did. I said
Yep.
there's 2 less green.
Top right.
Anybody got this one?
Yeah, I do.
JT?
I don't have that one.
Well, I just want to know if anybody has something to say of this one. It's the only one that hasn't been chosen. Yeah.
It has 2 less of green. Needs more green.
2 less of green.
Yeah.
Okay, it's the only one where green is at 90 degrees as well. Okay, again, whatever one you pick, you got to be able to defend it. Next page. Directions. Jackson Brantle. Read it.
Your teacher will give your group the supplies for one of the 3 different simulations. For these instructions to simulate 15 days of Diego's walk, the first 3 days have been done for you. Simulate 1 day. If your group gets a bag
You
of
can just read the bottom bullet there. That's what we'll be doing.
if your group
Yes.
Okay. If your group gets a spinner, spin the
The
spinner.
bottom bullet of that group, please.
If your group gets 2 number cubes, roll both of the cubes and add the numbers that land face up. A sum of 2 through 8 means Diego has to wait.
All right. So that's what we're going to be doing. Rolling 2 dice. 2 through 8 means he has to wait. We're going to record it in a table, calculate the total days on a graph. We're going to plot it, and so on. So let's complete the table. This is going to be similar to what we did the other day. I don't remember what that was, though. We were rolling dice for something. We were looking for 1 or 2, if I remember right. All right, so this one we're looking for 2 through 8 sum. Sum of 2 through 8. Okay. So they got 3 done for us. So we're going to start at number 4. Here we go. Yes or no?
No.
Okay, so 2 through 8 means he has to wait, so this would be a no. How many total days did we have to wait?
2.
Still at 2. That's 2 out of 4. Decimal equivalent. 0.5. Might be good to have your calculator out here. Guessing there'll be some we won't have memorized. Next one. 7. Have to wait?
Yes.
Yes. 2 through 8 has to wait. Number of days total?
3.
3 out of 5. Got that one memorized?
0.6.
0.6. 5. Have to wait?
Yes.
Guys, 2 through 8 is yes. Is this between 2 and 8?
Yeah.
Yes. Number of days? 4. 4 out of 6 reduces to 2/3. Got that one memorized? Very good. 0.6. 3. Gotta wait? Yes. Total? 5 out of 7.
0.71.
5. Gotta wait?
Yes.
Days?
6.
Out of?
8.
Got that one memorized? 6 out of 8 reduces 3/4.
0.75.
0.75. 8. Yes. Total? 7 out of?
.7 repeating.
I'll go about 0.78 then. I'll say about on that one. 8. Yes.
Yes.
8 out of 10.
80.
0.8. 12.
No.
No. So still at 8. 8 out of 11.
.72.
6. Gotta wait.
Yes.
That's now 9 out of 12,
3/4.
which is
175.
3 left. 6.
Yep.
That would be a total of 10 out of 13 now.
.76.
7
Yep.
total out of
.78.
No.
Repeating.
173.
7.3 repeating. All right. Now put those dots on this graph. So we're at 4. What was the decimal on 4? So at 4, put a dot on 0.5. 5? 6? 6 was 0.6 repeating, right? So a little above 0.65. 7? 8? 0.75. 9? 0.78. 10? 0.8. 11? 0.72. 12 was 0.75 again. 13 was 0.76. 14 is 0.78. 15 was 0.73. All right. Based on this data you collected, do you think the fraction of days that Diego has to wait after the 16th day will be closer to 0.9 or 0.7, and why? Raise your hand if you could answer. Do you think he'll be closer to 0.8 or 0.9 or 0.7? Leerud?
0.7.
Why? Yeah, well, look where it's starting to level off to. Are we leveling off closer to 0.7 or 0.9? Is our decimal starting to get close around 0.7 or 0.9? Absolutely, 0.7. Can tell that by looking at table or graph. It's leveling off. All right, so we finished with 11 and 11 out of 15. Still looking for 2 through 8. Cameron, do you want to come and roll for us? It's all yours.
Do I have to write it down?
Yeah.
Oh gosh.
You guys help her out.
I can't see it. 10. No. Wait, what do I
It'll still
put?
be 11. 11.
11? And then 11 out of 16.
11 out of 16, then you'll wait for them to give you a decimal.
0.68. So they do 0.6875.
Yeah, 0.6.
685.
Can't see it.
Wait, what can you not see? Here, I'll put over here.
Yes.
Got a little bit of a slant.
Mm-hmm.
What are we doing, Cameron?
This is hard.
All right, so how about
Where's the...
we do this
Should I come out of an angle?
and roll right here.
Okay.
But now, did you guys write down 17? No?
We can
Okay,
just do this
okay,
one.
do this one for 17 then.
Yeah.
I got, I have
already did
17
the
down.
I already
Yeah,
have
I had
this
one
again.
with 12 or 17.
Yeah, go by what the teacher has.
This is 6.
I don't ask her. She's got the book.
Teacher,
Yes,
do
yes.
I have to rate
Wow.
it?
I'm going.
That's 12.
12, put 12.
Over 17.
What's that?
0.7. Me too.
Ready?
Yeah.
Yeah.
13. 13
Not
over
18.
17.
18.
That's what I said.
You said 17.
0.72.
0.72.
Repeating.
I'm just gonna put 9.
13. 13 out of 19.
0.68.
Yes.
That's 14.
Yeah, we're doing a good job.
0.67.
What?
Doing a good job.
0.67.
Okay.
I'll just take a nap and let you cover.
No.
It's
No. 14.
0.63.
Oh.
What is that? 14.
This is a weird one.
How do you get handwriting that good?
Is that
Is it?
sharp?
And then there's me.
It's a 0.63.
Book's starting to slide a little bit on the other camera, off the camera. There
That?
you go.
That's yes.
No.
Look.
You know what's in a roll, Cameron?
14.63. 0.63. 0.60.
It's a weighted dice.
0.63?
Can't be the same as the last one.
Oh, I
It's
can't.
0.6.
How can all those be 0.63 in a row?
That's what they're telling me.
Number 20, I'm pretty sure.
Well, that's what
Yeah,
I
that's
think.
right.
Isn't it 2-3, not 6-3?
2, 3.
All right, Cameron, 14 out of 21, back up there.
Where? Right here?
Yeah, a bunch of those are wrong, guys.
That'd be 0.66.
14 out of 20 is
It's not our fault.
14 out of 20 is.
We
14 out of
we were
20 is-
believing Jackson.
It's
Jack.
0.66.
14 out of 20 should be 0.7.
Yeah, that's what I said.
No, you didn't.
You
No,
said
that's what I heard.
Okay, and then 14 over 22
Yeah, look,
is
I wrote it down too.
0.63. And then,
14 out of 21 should be 0.67.
yeah,
Okay.
and then
14 out of 22 should be 0.64.
Who's telling me this stuff?
Jackson,
Was it me?
Randall.
14 out of 23
I
should be
haven't even said
0.61.
0.6.
I've
This
said
one?
Yes.
Two things.
Okay.
I've written all these stuff down, Jackson. But I don't know what you're talking about.
All right, continue.
This is the next one.
Yes.
Yeah.
Yes.
I think Jackson Bronco was 0.62.
0.625, yeah.
0.62.
We sure about that?
Yeah.
Yes.
I think we are.
Probably check that. I haven't even said the word Jackson.
You just said
0.64. What about this?
I'm gonna double check that.
Yeah.
I wasn't talking to you.
Yeah. 77. Jackson.
Yeah, it's 0.64. Yep.
Okay.
All right, we good?
Yep.
Stop farting at
Oh, that's disgusting.
All right. You can see how much trouble it is if somebody's shouting wrong answers at you, right?
You are nasty.
Okay, so you could graph those as well. We're not going to. We're just going to discuss where they're going to level off pretty close to. Yeah, maybe even 0.65. Around 0.65 the way it looks. That's pretty close. Okay, so it's going to be just a little bit lower than where we finished off there. Question 3, what do you notice about the graph? If we were to plot them all on there, it will level off around 0.64, 0.65, somewhere in there. Okay, so estimate the probability he'll have to wait. Let's do it as a percent based on our experiment. As a percent, about 64% of the time you'll have to wait based on our experiment. All right, are you ready? On the next page, we are going to do, let's just do number 1. Let's look at the values and why they tend to not change after doing the simulation many times. Number 1, Abby.
After doing this simulation 4 times, a group finds that Diego has to wait 3 times. What is an estimate for the probability Diego has to wait based on these results?
All right, so right now we're saying they did it 4 times. They did an experiment like this, had to wait 3 of them. Now you're going to do another one. Another simulation. What are the 2 possible outcomes? Well, if you roll the dice, he's either going to have to wait or not, right? So there's 2 possible outcomes, either wait or not. If he has to wait again, what will the probability now be?
75.
No, this is what we're starting at. Now we're doing it again. So how many total of experiments have we done? They did 4, we do 1. So our denominator is going to be 5. Okay, he already had to wait 3 times. So if he has to wait again, that's going to be a total of 4 times he has to wait out of 5. The other option is he does not have to wait. So if you had 3 out of 4 waiting, and now he doesn't have to wait, what's my fraction going to be here? 3 out of 5, absolutely. All right, can you give me, let's go as a decimal on this one. 4 out of 5 as a decimal. Somebody other than Matthew and Lerud. Yes.
4 and 5, I think it's 0.8.
Okay, how about 3 out of 5? 0.6. All right, what is the difference between the possible estimations after 5 and the estimations after 4? Well, what's the difference mean? Subtract. So let's look at weighting. 4 out of 5 minus 3 out of 4. Let's get a common denominator. What's our common denominator to subtract those? 20. So what do we take the first one times to get 20? What do we take 5 times to get 20? 4?
4, yeah.
So 4 times 4? 4 times what is 20?
5.
3 times 5?
15.
15. So weighting will change it by how much? What's 1 out of 20 as a decimal?
1.5.
Use your calculator, Jackson.
0.05.
0.05 or 5%. Okay, so drawing or rolling a weighting will change it 5%. Would change our last column 5%. Let's see how much no weighting changes it. Okay. Now I gotta take 3 over 4 because that's bigger out of the two of them, minus 3 over 5. What's our common denominator? 20. What do I take the first one times to get 20? 5, so 3 times 5. 5 times what is 20? 3 times 4. That's going to be 3 out of 20. What's 3 out of 20 as a decimal? So 15%. Okay, so drawing a number that would make them weight changes it 5%. Drawing a number that doesn't make them weight changes it 15%. Last page. You have to describe an experiment. Tell me what you would design to do a simulation, kind of like we just did with the dice, of the following situations, what you would use. Okay, so first question. Trey. 6 people are going out to lunch. One of them will be selected at random to choose where they go. What would be a good way for you to design an experiment to represent that?
Roll a dice.
Roll a dice. Why?
There's 6 sides on it.
6 sides. And each person could choose one restaurant. 1 means Jackson's picking, or 2 means Dieterle's picking, 3 means Cameron's picking, and so on. 6 people.
What number would you want to pick?
3.
Question 2. After a robot stands up, it will be equally likely to step forward with its left foot or its right foot. Which foot will it use for its first step? Cameron. Flip a coin. Why? 2 sides, because it's either going to walk with left foot or right foot. So you could say, like, heads is left, tails would be right. Question 3. In a computer game, there are 3 tunnels. Each time the level loads, the computer randomly selects one of the tunnels that leads to the castle. Which tunnel are you picking? How many sides on the spinner? 3 sides on a spinner. Okay, so you could probably even show that. Spinner 1, 2, and 3. Tunnel 1, 2, 3. Spin it. Could have also said dice. 1 and 2 could go to tunnel 1. 3 and 4 could go to tunnel 2. 5 and 6 go to tunnel 3. That's a 1/3 chance still. Anything with 3. Coin would probably be pretty tough. Drawing marbles. 3 marbles. Question 4. You're taking 4 buses on a field trip. You'll be assigned to the same bus that your math teacher is riding on. So something with 4. A good simulation. Yeah.
Like drawing like a cube or like what we did yesterday. Like 4 cubes.
You could have 4 cubes, 1 representing each bus.
Or like a spinner.
Could make a 4-sided spinner. Anybody know how we could use cards to represent this?
There's 4 cards, kings, queens, and
1, 2, or
Draw
2,
4
3, 4,
marbles.
5.
Play pinochle and the winner.
Yeah. You could also just choose a suit. There's 4 suits in a deck of cards. Hearts, diamonds, clubs, and spades. Or you could just have 4 cards and draw like you were mentioning, yes. Yeah.
how many sides is how many numbers are on a dice?
6.
I never said numbers, I said sides.
Still the same thing.
It's still
Same
six.
right.
There's not going to be 4.
All right, so if it says design, make sure you explain what you're designing. Okay, your homework starting on page 49. You're going to draw a spinner, and then you're going to describe another way you could do that. Okay, 75% chance of rain later today. Question number 2. An experiment will produce one of 10 different outcomes with equal probability for each. How could you use a dice to help you with that? How could you use a dice to help you with that? Notice it says it would be a bad choice. Why is it a bad choice for that experiment? Question number 3. Talking about an ice cream shop. Picking your favorite flavor. See what you think on that one. Answer that accordingly. Question number 4. Which one of the following cannot make a triangle? We had a little rule for triangles. Hopefully you can remember that. If not, look back. Should be able to handle it. And question number 5, kind of a review from constant and proportionalities. There are 5 questions. Then there's a graph for you on the next page as well that goes with it. So 1 through 5, it's on 2 pages except for that graph, page 49 through 51.